a pterodactyl. Is there any relationship between the ptera and pterodactyl and the ptera and pterodophyta? Yes. Well, the time period is actually similar, but that's not what that means. It's not that P-T-E-R-O. Like what kind of dinosaur was the pterodactyl? A flying one. It had wings. It didn't have feathers, but it did have wings. Well, oftentimes ferns look like feathers. This looks like a giant feather if you use your imagination a little bit. So it doesn't exactly look like a wing like a pterodactyl. And pterodactyls definitely were not the feathers of the dinosaurs. They definitely were, but they came.
Not the dinosaurs.
Yeah, the pterodactyls, exactly. The pterodactyls were not feathered. Later flying dinosaurs were. Yeah, flight has evolved independently like 5 times. It's wild. Pterodactyls? I mean, I personally haven't seen the fossils, but the people who study them have convinced me that yes, they were for sure not feathered.
I've been convinced by others.
Yeah. But pterodactyls were from a very different lineage. Anyway.
I think most of the other ones actually did not fly.
Dinosaur.
Yeah, they
Flight it.
All right. Now we are going to talk about. Okay, thank you. We're just going to go back. That was bad. Let us go.
Yeah, why did they say?
Yeah,
Why did they say that was
They
okay?
don't care about our
They don't
lives.
night. Look at that.
The hallway smells like gas. Why would they let us out in the room?
They don't care if we live or die.
All right, guys. So, yesterday in the classroom, we didn't see this in the greenhouse, but we did in the classroom. We're going to expand on it right now. And there's none right here that I can just go grab for you, unfortunately. This represents a plant that's called a horsetail. Did you all see this in the classroom yesterday? It was like a potted plant towards the end. Okay. And then at the tops of some of the stems, there was this structure right here. This is what we're going to expand on for my next drawing, my next piece of art here. What is that structure at the top?
Strobolus.
It's a strobolus. Yes, I'm not going to write that here because this chalk goes so fast. It's crazy how fast it goes. This is a strobolus. Remember that word strobolus? It's another kind of fancy word for cone, and it looks like a cone. What I mean by fancy word for cone is it's composed of a bunch of these very tiny repeating units. And that's I kind of tried to represent that in my chalk drawing here by making it checkerboarded. Can you guys all be quiet, please? So the checkerboard representing each little square there is a part of this strobolus. And so that's what I'm going to expand on right here. I'm going to take one of these little parts of the strobolus that was supposed to be a circle around one little part. And we're going to kind of blow that up right here. Now, the strobolus is, I'm going to kind of do it so that it's that orientation too. The strobolus is made up of these repeating units that are called sporangiophores. Sporangiophores. Yeah, this is new. That word sporangiophore, it's not found in all seed-free vascular plants. In fact, it's only found in this phylum, which I meant to ask you this a minute ago. What phylum is this again?
Sphenophyta.
Yes, Sphenophyta. Sphenophyta or Sphenophyta. That's the phylum of horsetails and their allies. So this little umbrella, sideways umbrella-like structure is called a sporangiophore. Question?
I was going to ask about like what they look like.
Yes, this is the beginning of it at least. This is the actual sporangiophore, and it's a longitudinal section through it. What I cannot draw is the fact that these things are actually very three-dimensional. Like even if I didn't have chalk, even if I had something better, there's no way I could draw that. Because, yeah, and just use me right now, just picture like, it's in the shape of a mushroom, really. It looks like a mushroom with the stalk and the cap. And so if my arms here were not individual arms, but my motion here was like making a solid shape, then I would look like a mushroom, more or less. Do you see what I'm saying, kind of? Like imagine that my body is sort of like a mushroom. My arms are all connected and webbed, and I have lots of them. I don't know. Well, on the undersides of this mushroom cap, which this is the longitudinal section through, is where sporangia. So this thing also has a bunch of sporangia, but in our little section right here, you can only see like a couple of them. But they form a perfect circle. Each one of these repeating units of the strobilus is one of those mushroom-shaped structures. Each mushroom-shaped structure is bearing a dozen or so sporangia. Yes?
So are these like the equivalent to sporophyle, but just for this
Yes.
specific species or genus?
Yes, they are. Remember, and yes. So remember the sporophylls that we introduced in lecture on Monday? You saw it in lab yesterday in the Selaginella and the Lycopodium. Those are the two life cycles that we're going to talk about probably on Friday's lecture. And those ones have a strobilus with a sporophyll. And I told my class this, those sporophylls are like arms and the sporangium is like a bicep. There's one sporangium per sporophyll in the things that have sporophylls. These don't have sporophylls. Instead, they have these sporangiophores. They are equivalent evolutionarily, yes. But these have several sporangia, like a dozen or so, per sporangiophore. Yes. And there's 100 or so, probably more than 100 of these sporangiophore on the strobilus. There's a dozen or so sporangia on the sporangiophore, and inside of each sporangium, hundreds of spores. So one strobilus is producing tens of thousands of spores. Wow. The truth is that from this stage here, the sporangia with spores, the rest of the life cycle is actually the same as the ferns. Those spores, which are now haploid, they were just formed via meiosis in the sporangium. Well, these spores will be released. It'll start off as a little spore. That spore will become a gametophyte. That gametophyte is bisexual. It is bisexual just like this one was. It has antheridia and archegonia. And from that gametophyte, you'll have a new horsetail. Yeah, so I just kind of skipped through a lot of that life cycle for this one because we already kind of went over the important parts of it in the fern.
Question behind you, Stephanie.
Question, yes. Well, it was just the sperm that are swimming through water. And yes, since these are bisexual, hopefully there's a bunch of gametophytes right next to each other. The sperm are released and they swim to a nearby gametophyte. But these spores from the strobilus, as well as these spores from the sorus, or the sporangia within the sorus, they're airborne. Yep. And then they want to land somewhere that's just right. It's the perfect environmental conditions. Yeah, exactly. The sperm, they're restricted to aquatic areas, wet areas, not like a literal pond or something.
Do the horsetails also grow rhizomes and they also grow fiddleheads before?
They sure do.
Is that
Yes.
rhizomes?
So from here, this new sporophyte, which right now I don't have my green chalk. This circle at the bottom is the haploid gametophyte. This erect part is the sporophyte of the next generation. And sure enough, yes, just like that, you're going to have a rhizome. And most of the horsetails that you see are not formed from a gametophyte. Most of them are formed from a rhizome. They do tons of asexual growth this way. Right? Raised rhizomes. Remember that organ modification? The whole point of a rhizome is to spread yourself asexually. To make more bodies without having to produce a whole spore and a strobilus and all of that very expensive stuff. So they do this a lot. And a lot of times when you see a big patch of horsetail, that might just be one genetic individual. Yeah. Yeah.
Is that why they're so hard to control?
Yes. Yes. So you might know this. Horsetails can take over an area. It's because of this rhizomatous growth. They're so good at doing asexual reproduction. Yeah.
So if you were to somehow find that one horsetail with the Sphenophyta on it, would that stop it?
Yes. That would start the beginning of this. That would stop the beginning of the spread. Yes. But if you wouldn't, if you found that gametophyte right here, it's not like this one would die.
Okay.
So only this first sporophyte, this first young sporophyte, and same with the fern, only this first young fiddlehead sporophyte, are dependent on the nutrition from this gametophyte. After this rhizome grows, they're getting all their nutrients from the results of photosynthesis. These things, by the way, oh yeah, that's what I was going to say. In the horsetails, these radiating structures, they're kind of acting like leaves. They're definitely green, but they're actually not. They're modified stems. So all of those radiating things, they're just stems. But when you look really closely, did you guys see this? Right at each node, there's this whirl of vestigial leaves. You guys know the word vestigial? From like another class, maybe I don't think I've looked at this. What
It's
is
like
it?
not needed anymore, but it's like still there, but kind of evolutionarily fading out. Don't need it
Exactly.
anymore.
That's a perfect explanation, yes. Vestigial just means something that it's there, but it's no longer useful. In its evolutionary history, that thing was useful. These used to be nice green, spreading leaves that were probably doing photosynthesis, but they've been reduced to these scale-like structures. Unfortunately, they're green with my chalk, but I swear they're not normally green. They're brown. The green parts of this body are actually the parts that I had in yellow. Sorry. Yeah. So actually, even on these radiating stems, you might see little vestigial leaves. Yeah. Can I get a quick time check?
It's 12:40.
All right.
Slag.
Yeah. Thank you guys. Yeah. Question.
With the rhizomes, like how they're under the ground,
Uh-huh.
is that why it's so hard to clear invasive species because they like spread under the ground and can't climb?
Yeah. So the fact that the rhizomes are under the ground, the question was, since the rhizomes are under the ground, is this why they're so good at being invasive? Is this why getting rid of invasive plants is so difficult? Sometimes yes. And in the case of equisetum, and at least some ferns, there are some invasive ferns, their rhizome can actually be 6 feet underground. I'm sorry, what? 6 feet underground.
What?
This rhizome.
Oh my gosh, that's crazy!
So why that's so important?
It's not
there's this-
special.
There's this one fern who has these rhizomes 6 feet underground all the time, and that one tends to grow in really dry forests where fire happens. So everything above ground will have gotten crispified. It is now dead, which means it has no competition for light. And so those deep rhizomes, they get some signal that there was recently a fire, and they start shooting up leaves. They're the first thing to come up after a fire, and they are super invasive for that reason. This is one specific type of fern that I'm talking about, but there's 12,000 species of ferns. Honestly, most ferns are not invasive, but some are. This one that I was just talking about is, yeah.
So how tall is the plant if they're 6 feet under? If this rhizome 6 feet under?
That one that I was just talking about, it can have leaves that are about 15 feet tall. Yeah, and that's not like the tree ferns that I was talking about we saw. I'm talking like a single leaf coming from the ground can be 15 feet tall. Up to 15 feet tall. The one that I'm talking about right now is called the bracken fern, if you were wondering. I used to have some in my backyard when I used to live up on Pickle Hill. They're here. They're here. So we have a bunch of them on campus, but the ones that are on campus aren't that tall. And also this is the wrong time of year to be seeing them. But they can get freakishly tall, yes. Comment? Yep. Oh, I bet. After the car fire around Whiskey Town. Yeah, all of the fires, right. Yeah, so around Whiskey Town is a good place to see some of those ferns. Other questions?
Yeah, so are the vestigial
Yes. The question was, are these vestigial leaves the only ones that are on the horsetail? Yes.
So, follow up. If they're vestigial, then are there plants that just straight up don't have leaves at all?
Well, the plants that don't have leaves at all are bryophytes. They're evolutionarily, they came before true leaves. So no, in theory, I love doing that. It always puts a nice cushion to what I am about to say. In theory, every vascular plant has true leaves. Yes. Yes.
Could these plants not have leaves at some point?
Yeah, I mean, they're so pointless that maybe it would make more sense for them to remove them. You know, that might be beneficial. What if maybe they cause some hindrance? Maybe they attract insects that then eat the plant or something. I don't know, I just made that up. But you know something else that's vestigial that causes a huge problem, and it would be so much better if evolution would just get rid of it? Your appendix. Yes. And I think I'm gonna leave it there for now. It's too hot. Thank you so much for your attention.